Good morning, everybody. Hopefully everyone's doing well. If you can give me a green check, we'll get started once everyone chimes in. We're going to start Unit 6 today. There's only 6, 7, and 8 left. Crazy. I know you guys are talking about in chat how fast November went, and it's kind of weird the first semester because you have the winter break and then you're done. Like you only have a couple of weeks in January to kind of finish things up. So you think November went by fast. December, there's only 3 weeks of class, and then January we only have 2 weeks in exams. So it's gonna fly by from here on. I'd like to go through Unit 6, Lesson 1 first, and then if you had anything from Unit 5, I should say, that you kind of unsure of before you submit that learning guide or go through that test, I could find some time to do that. So let's jump right into Lesson 1, Unit 6. Looks like everybody's ready to go. The funny thing about Unit 6 is that some of the things we talk about in Unit 5, we talk about again in Unit 6, things like slope of a line, but we look at it a lot more closely. So it's kind of weird how the units kind of pop up. Sometimes it makes more sense to do Unit 6 first and then do Unit 5. That's why I kind of mixed up the units, but we'll just kind of stick with it and go from here. So the first thing we're going to do in Lesson 1 is just talk about the slope of a line, and we've talked about the rate of change so far in Unit 5, which is the exact same thing as the slope. So rate of change, slope, rise over run, these are all sort of synonyms for one another, all the same word, just talking about the same thing. So we should define slope here as a measure of how one quantity changes with respect to another. And sort of one word that comes up a lot with slope is change. We talk about the change in the x-axis, the change in the y-axis, how one quantity is changing with respect to another. And change, we'll look at it, it just means you start somewhere, you end somewhere. What was the change? What happened between your start and your end? So let's kind of look at what slope can equal. So slope is equal to, the easiest way to think of it is rise over run. That's just what slope is. Another way we can define slope is change in y. Remember we talked about the Greek letter delta or the triangle being change. So let's go back here. The triangle means change. So we have a change in y over a change in x. Now if you think about it, y is the vertical axis, so that is the rise, and then x is a horizontal axis, which is the run. So rise over run, change in your vertical over the change in the horizontal. And then from the last unit, we talked about slope also equaling the rate of change. So from Unit 5, slope, rate of change. So these are all different ways we can represent the slope, and just depends on sort of what the circumstances are. And we'll pick one of the sort of 3 different ways. It's not important that you remember the ways, it's just when you're going through a question, maybe it's like a word problem, and it asks for the slope, it's probably talking about the rate of change. If you're looking at a graph and it has lots of little grid points on it, rise over run will work. And then change in x over change in y, we'll actually get into that a little bit further on when we start actually calculating values for the slope from lines. So there's a little picture here. Now, when we say change or rise and run, change in x, change in y, so rise is the change in y, run is the change in x, what we mean is, just like when you read a book, you start at the left side of the page and you work your way across to the right. So when we talk about change in math or looking at these graphs, you're always going to read a graph from the left side, to the right side, going from left to right. So the idea here is that if I started at a point, like this guy right here, and I said, okay, there's my start. I'm starting at the left. And then I go to the right, which is my end. And I have 2 points. I have this point here and this point here. And I want to know the slope between those points. So if I'm going, okay, how much do I need to rise? So I'm going up, 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 up. Okay, there we go. There's my rise. And then my run. So going from left to right. So those are the kinds of things that you're going to get used to doing. And it only works if you go from left to right. A couple other things we should include. We've actually talked about these a little bit. If I have something, if I'm going from left to right, and it's going up to the right, this is a positive slope. If I have something that is going down and to the right, this is a negative slope. And we talked a little bit about that sort of idea when we were dealing with rate of change. We had things like filling a tank up, kind of went, up, and then emptying a tank went down, reading from left to right. So these are just things that as you go over them again and again and again, they'll just become second nature, but right now it's kind of the first time you've seen them. One other thing I should mention, if we have something like that has a negative slope, rise over run doesn't necessarily make sense. So for negative slope, think about fall over the run. Because instead of going up, you're not going up. You got to go down and then over. So when we're dealing with a negative slope, if it makes more sense reading from left to right to go fall over run, then you can go ahead and do that if that helps you kind of work it all out in your brain. All right, so there's some little graphs here, and we're going to figure out the slope of each of these lines. So 4 examples here. And they are basically the only 4, like the slope, the actual value for slope will change, but these are the only sort of 4 things you can have. You can have the first one is a positive slope, the second one's a negative slope, and then the last 2, we're going to look at these ones and try to figure out what those slopes represent. They're kind of the special cases. So there's only sort of 4 scenarios: positive slope, negative slope, a horizontal line, or a vertical line. Those are the only things you can have. I mean, the line can get steeper or shallower. The slope can increase or decrease, but this is it. So the key to finding the slope is to find some points on the line. And what I mean by that is, in order to find the slope, you need to have at least 2 points. And if you can find points that are on perfect intersections, on perfect grid lines, those are the ones you want to start with. So if we look at the first example here, I'm going to look really hard and see if I can find a couple points that are on a perfect grid line, like a perfect grid intersection. So I can see one right here. That one's nice and easy to deal with because it's right on that y-axis as well. And it kind of looks like this point up at the top here goes through a perfect grid line. Now, one thing we'll talk about a little bit later is that the slope of a line is consistent. So any 2 points on the line, doesn't matter where you pick them, are always going to give you the same slope because the slope of the line doesn't change. So if you pick different points than I included here, that's completely fine. You're going to end up with the right answer. So there's no right points to pick. Any 2 points on a line will always give you the right slope. Sometimes picking certain points will be easier, but that doesn't necessarily make different points more correct or incorrect. So the idea for slope And one thing I didn't define, but I will right now, another way of representing slope is the letter M. And you're thinking, Mr. Borden, you've lost your mind. M, that doesn't make any sense. But the letter S for slope, the letter S could be like speed. S was already taken. So we have M, and M is slope. I didn't come up with it, I'm sorry. Okay, so when we talk about slope, we start at our point on the left and go across to our point on the right, and we read it from left to right, and we start and we go rise over run. So if I start on the left and I say, okay, how far do I have to rise to get to my second point, which is on the right? So how far do I have to go up? So I go up, 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 up. So it looks like I'm going up 1, 2, 3, 4. So there's my rise. And then my run is going from left to right. How far do I have to go from here to get across to here? So it looks like I'm going over 2 units. So if I were to write my slope, I'd have M is equal to my rise, which was 4, and my run, which was 2. All right, so rise over run, 4 over 2. 4 over 2 can be simplified a little bit because 4 divided by 2 is just 2. So the slope of this line is equal to 2. And you're thinking, 2 what? Well, it doesn't really have units slope. It is just, well, I shouldn't say that. Slope has units, but because our graph is just x and y, there's no units associated with it. So the slope is just 2. And we can compare it to other slopes in terms of value, a slope of 2 or a slope of like 10. It's just going to be how steep the line is. So let's look at the next example here. And I'm going to start at the same process. I need 2 points, and I'm going to try to find points that are perfectly on grid lines. So if I look, it looks like there's one here that's perfectly on a grid line, and then I could probably find another one, maybe this guy over here. It looks like there's a few more than that. You could probably do this guy at the end as well if you wanted. It doesn't matter. Any 2 will do. So again, we're going to start at the left point, your left, which is my right, and go across from left to right. And we're going to see what the rise is, and then we're going to divide it by the run. You could maybe see the problem we're going to run into here is that we are not going to be able to rise to get from our left point to our right point. So I start here. If I were to go up, it wouldn't make any sense. I'm not going to ever get to the second point over here. So I'm not going to rise. So that means this is a negative slope. So I should expect that my values should be negative. So instead of going rise over run, I'm going to have to go fall over run. Now, I'll always say slope is rise over run, but if we have a negative slope, you're going to have to be able to recognize that. Even though it's fall over run, I'll always say rise over run. So we're going to go down. We have to go from here down to there to get to where that second point is. So that looks like I went down 3 or negative 3. And then my run is going from this point to this point. And that looks like a value of 5 because it's going to the right, it's positive 5. All right, so my slope is equal to my rise in this case is negative 3 because I went down 3. And then my run is going to be positive 5. Now I can't reduce that any further, so I can just leave it like that. And Abby's asking, should we just leave the negative on the top? Yeah, we will always put the negative sign on the top. And I kind of alluded to that when we were dealing with fractions before. You can put it on top, you can put it out front, you can put it on the bottom, all are correct. But for the case of slope, I like putting it on the top because that means it's always going to be, my rise is possibly going to be negative. It might be a fall if it's negative. Then my run is always going to be positive because I can always go from left to right. And yeah, so there you go. We're done with that guy. Let's go to the next one. This is a bit of a strange one, but these are kind of the special cases of slope. So I picked 2 points. Pick your poison. Any 2 points you want. Let's pick one here and one there. Those go through grid lines perfectly. I know slope, or the letter M, is going to be rise over run. Now, if I go from left to right, how far do I have to go up to get from my left to my right point? I'm not talking about run, but I want to talk about rise. How far am I going up? It's a horizontal line. Do I have to go up at all to get across to my next point? No. So what value would I use to represent my rise? 0. So my rise in this case is 0. My run is going across. In this case, my run is 1, 2, 3, 4, 5, 6. So my run is 6. So I get 0 over 6. All right. Alex is citing me for a mathematics violation, saying it's illegal because you cannot divide 0. Funny thing in math, Alex, is you can go 0 divided by a number. You can put it in your calculator if you want, and your calculator will give you an answer. You cannot divide by 0. So you can't have 0 in the denominator. You can have 0 in the numerator. So if you have a calculator handy, you plug it in, you go 0 divided by 6, and you end up with just 0. So the slope of this line is 0, or you could say there's no slope. If that makes sense. So we can go 0 divided by a number, which is interesting because when I went rise over run, I could have picked any run I wanted. That line segment could continue on in both directions forever, and I could have a run of 7 million if I wanted, and 0 divided by 7 million is still 0. So it doesn't matter what your run is. If you have a horizontal line, the slope is 0. Let's look at the second example here to kind of compare the two. Again, I'm trying to find slope. I'm going to go rise over run. So I'm going to pick 2 points, any 2 points. Let's go this guy and that guy there. So if I do rise, I've gone up by 1, 2, 3. So my rise is 3. My run is going to be what? How far over? I guess I've been doing blue as my rise. How far over do I have to go to get from one to the other? Alex is a bit ahead of me here. Yes, this one is definitely illegal, breaking mathematical laws everywhere. My run is 0. So my slope is, now 3 divided by 0, in your calculator, it's going to give you an error. In math, we say this is undefined. Or you could say the slope is undefined. So this is kind of one of these tricky things with slope. If we have a vertical line, our slope is undefined. We can't define what that is because we can't divide by 0. But if we have a horizontal line, we say, oh, the slope of that line is 0 because the rise was 0 and the run was a number. So 0 divided by a number is just 0. That's defined. But if we have a vertical line, it becomes undefined. So that is kind of the 4 scenarios you're going to run into. If you always go from left to right, you can have a positive slope, you can have a negative slope, you can have a horizontal line with 0 slope, or you can have a vertical line with an undefined slope. That's it. Those are the only 4 scenarios you're going to run into. And one thing that's important is that when you are calculating your slopes, you should always reduce your values. So try to get your slope in the simplest form you can. So like right here, 4 divided by 2, we said, okay, 4 divided by 2 is 2. We've reduced it as far as we could. Let's mosey on to the next example here. Alex has another thought-provoking question. Would you say the definition of powers is how many times you're going to times 1 by that number? Like 5 to the 3 is 5 times 5 times 5. I'm confused as to why. I don't think that sort of as a definition works. Because, I mean, I guess it could. You can multiply by 1 if you wanted. I don't know. Strange question. I don't know where that's coming from. So it's not like a fraction, you don't simplify as a fraction. Yeah, it is a fraction, Taylor. And if you can simplify it as a fraction, you should. So if you have a fraction of 4 over 2, simplify it. If you had something like 8 over 4, or if you had 3 over 12, you know you're going to reduce 3 over 12 to 1 over 4. It's a quarter. So whatever the fraction is, you're going to just put it in simplest terms. It makes your life easier. If you think about 3 over 12, trying to plot 3 over 12 as a slope on one of these graphs, you're going to run out of points because it's just so big. But 1 over 4, that's going to fit. It's a little bit simpler. Numbers are easier to deal with. All right, so we have 4 examples here of slopes. And these examples are working backwards. So on question number 1, we were given a line, asked to find the slope. So we went from left to right. Now we're given a slope and asked to draw the line. So let's start with RS here. RS has a slope of 4 over 9. Remember when we have a slope, we just have the rise over the run. So I can pick a point on my graph. Doesn't matter where it is. Somewhere on the left side will make my life a little bit easier. I'm going to pick a point right here. You don't have to pick that point. You can put a point wherever you want. I'm going to always go from left to right. So I'm going to move my way across this chart, going to the right. And I'm going to use a rise of 4. So I'm going to go up 1, 2, 3, 4. So there's my rise of 4. And my run of 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. I'm going to put another point there. So I've gone up 4. I've gone across 9. We would typically call our first point R and our second point S. Just like we read from left to right, we would identify our points going from left to right. Left would be our first point, right would be the second. So I have 2 points. I'm going to break out my ruler. I'm going to attempt to connect these 2 points with a straight line. That was not a very good one, so I'll try again. That's about as good as I'm going to get. So there we go. There's a line segment with the slope 4 over 9. I'm going to do the same thing with my next one. Let's maybe pick red. So this is the rise and then the run. Now, before, I think it was Abby, you asked, the negative sign, does it go on the top, the bottom, or right in front? And I said, I always just put it on the top. So in this example, I have negative 8 over 3, what I'm going to do is I'm going to put the negative sign on the top. And that's just going to make it easier. I'm not going to get confused with my negative sign because I've put it on the top and I will consistently put it on the top. So the negative sign now is always going to be my rise. If that helps, I'm going to pick a point. Maybe this guy way up here. And I'm going to go from left to right. Now my rise is negative 8. So instead of going up 8, because it's negative 8, I'm going to go down 8 because it's negative. So here goes 1, 2, 3, 4, 5, 6, 7, 8. There we go. So we've gone down 8. And my run is 3. 1, 2, 3. So there's my second point. And we're calling this point T and this point U. And we will connect those 2 points. A straight line. There we go. There's T and U. Anything divided by 0 should be infinity, because you can give nobody something infinity times, like I just gave nobody a cookie, and I can keep giving nobody a cookie infinity times, right? If it makes you feel good to give nobody something infinite amount of times, then I guess that's okay. I don't know if it makes sense mathematically to calculate it that way. We can go with it if you want. You can give me no cookies, Alex. All right, AB. Let's go with blue here. Rise over run. But I don't have a run. So what do? I just have a 4. I have a rise, no run. Does that mean it's a horizontal line? Does that mean I'm dividing by 0? What's going on there with just a 4? What am I going to do with that thing? Is it over 0? Is my run 0? Is my run something else? What do we think? 4. Just a 4. Think about this for a second. If I had just a 4 and I went 4 divided by 0, can I divide by 0? No, that's undefined. So that doesn't make any sense. Could I have 4 divided by 1? What does that equal? Well, that just equals 4. So Abby's on the right track here. If I just have a 4, that's the same thing as 4 divided by 1. I can divide anything by 1 and I just end up with whatever it was. So let's pick a point over here, give us some room. My rise is going to be 4, so 1, 2, 3, 4. Go up to there. My run is going to be 1, so I'm going to go across to there. So this is A down here, we have B up here. There we go, a line segment connecting those things. A over B. Rise and run. The last one's a similar sort of thing. I have -1. This is going to be rise over run. And my -1 is just going to be the same thing as -1 divided by 1. So I pick a point. My slope is -1, so I go down 1, and then I go to the right 1. I have another point here. This is M, this is N. I connect those 2 points with a straight line. There we go. So that's a bit of a mess. All of the little really fine lines I've drawn in here, you can just erase those if you want. You don't have to have those in there. It just kind of confuses things. I mean, you're not always going to be asked to draw a bunch of lines on one graph, but they don't necessarily have to be drawn. If you just have your lines, then that's fine. Okay. Example number 3, determine the slope of a line that passes through 4, -5 and 8, 6. So let's plot these 2 points on our graph, and then we'll see if we can go rise over run to connect the 2 points. So 4, -5. Remember when we have these points, our first is our x, our second is our y. So the x is +4. And then I go down 5. So 1, 2, 3, 4, down 1, 2, 3, 4, 5. So that's point E. And then I have point F is going to be 8 and 6. So 8 is my x, 6 is my y. 1, 2, 3, 4, 5, 6. Well, it's not going to fit. All right, so we're going to have to relabel our graph here. Sorry if you had gone ahead. We'll go up by 2s. So we'll go 2, 4, 6, 8, 10. +2, 4, 6, 8, 10. -2, -4, -6, -8, -10. Now everything will fit on there. Let's try this again. 4, -5 is our first point. Maybe right there. So that's point E. And then F is 8, 6. Really good question. For all the questions, do we draw the line extending past the points, or do we just connect those 2 points? Generally speaking, unless it says line segment, you're going to draw right through the points and continue on for the whole width of your chart. If the line were to specify a line segment from point E to F, then you would just connect the dots. So draw the line going from one side to the other all the way, unless it says otherwise. In this case, it just says determine the slope of a line. It doesn't say line segment. So if we have a line is going to continue on in both directions forever to infinity and beyond. All right, so I have 4, -5, and I have 8, 6. All right, so I have 2 points here. I'm going to connect them with a line, because it says a line goes through these 2 points. Ooh, that was a good line. Look at that, right through those. Good for me. All right, now I need to figure out the slope. So it's asking me for the rise, and then it's asking me for the run. From E to F, what's the rise? So E is on the left, F is on the right. We're going to go from left to right. Let's see what we can do here. If I go from E, I'm going to go up. What am I going to go? Up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Remember, each square represents 2. So my rise is going to be this little green line I'll put in here. I've gone up by 11 units. So my rise is 11. My run is going across, and each square represents 2. So I'm going over 2 squares, which is going to be 4. So it gets a little bit confusing because the graph we've drawn here, each square isn't representing 1 unit, it's representing 2. So if we have a rise of 11, a run of 4, we're going from left to right, we went up and then to the right, so it's positive slope. We end up with 11 over 4. And I can't simplify that any further, so that's just my slope, 11 over 4. And I'm just done. All right, so there's a formula we can use that'll work for any line if you have coordinates x and y. And that is indicated down at the bottom here. So if a line passes through any point A and B, could be any points, and A is an ordered pair xy and B is an ordered pair xy, because all points on a graph can be written as an ordered pair. If you take the y terms and you go y2 minus y1 and x2 minus x1, you end up with the slope, and you're thinking, Mr. Borden, those 2's and 1's are on the bottom. Shouldn't they be on the top? This is so confusing. I don't know what's going on. Why are you doing this to me? Well, think of it this way. A is the first point. So everything in A has these little 1's next to it. And then B is my second point, so everything here has little 2's next to it. So these are called subscripts, and they just kind of help us sort out more than one point. Because if you think about it, if I gave you 2 points, I said, okay, you have a point like 2, 3, and 6, 7. I said, okay, take the x point, the x coordinate of the point, and then you'd say, well, there's 2 of them, which one? I'd say, okay, well, how can we kind of distinguish between these 2 points? We'll call everything here, this is going to be my first point, so I'd have x1, y1, and everything here is my second point. So I'd have x2 and y2. So it's just kind of a way that we try not to confuse each other when we're talking about ordered pairs. If I had a third point, I could, put in a third point, and it could be, 7 minus 5, and this would be x3 and y3. So I could just keep doing that for as long as I want. The 3's don't go on the top. It's not x cubed or y cubed or x squared or y squared. It's just x with a little 3 next to it to indicate it's the third point. Generally, for slopes of lines, we'll only have 2 points. That's all you need to find the slope. So hopefully that kind of clarifies that. I know it can be a bit of a strange sort of thing. So what are we doing here? Well, we're taking the second y minus the first, and then we're taking the second x minus the first to get the change. So we could also write this as change in y over change in x, where change in y is the second y point minus the first, and change in x is the second x point minus the first. We can just divide those things. That gives us the slope. Might not make sense right now. Let's look at an example of it. Example 4, interpreting the slope of a line. Yvonne recorded the distance she had traveled in certain times. She began cycling trip across Trans-Canada Trail in Manitoba from Winnipeg to Grand Beach. She plotted the data on a plot. What is the slope of the line through these points? What does the slope represent? All right, so let's use this new fancy formula we just wrote down. Let's pick 2 points. And I'm going to maybe do this a little bit backwards. I'm going to call this point down here B, and let's call this point up here A. Why B and A? Well, they're just random letters, but maybe it might be a little bit easier here in a second to think of it this way. So we're going to take the slope, and we said the slope, in this case we're going to find the slope of the line segment AB, or the slope of the line that goes through A and B. Now we just said the slope is y2 minus y1 over x2 minus x1. All right, so what's the ordered pair up at A, and what's the ordered pair down at B? So A is going to be x value first, which is 3, and then my y value is going to be 72. And down here for b, I have 1 for my x value and 24 for my y value. I'm calling this point up here A. This is my first point. Call it x1 and y1. And then same thing down here with b. I have x2, y2. Now you could have called my point A your point B and my point B your point A, and you would have ended up at the same spot. So it doesn't matter which points you picked. You could have picked the middle point if you wanted. You could have called it letter Q if you like. The A and B are just completely arbitrary. Doesn't matter. And then the fact that I chose A to be on the far right and then B on the left, that was an arbitrary, well, it wasn't an arbitrary decision. It was a decision that I made to kind of simplify things, but it was just, it doesn't affect the outcome of the problem. All right, so I have 2 points. Maybe I'll rewrite them over here. I have my first point is x1, y1, and in this case it is 372. My second point is going to be x2, y2. A little comma in there. Now I'm getting myself confused. And my second point in this example was 124. So it's kind of like a substitution type thing here. We're going to take y2, which was what? Well, I said y2 was 24. So I'm going to put a 24 in for y2. Okay, y1. What is y1? Here's y1 over here, so I'm going to subtract 72. Okay, x2 is 1 from down here, and then I'm going to subtract x1, which was 3. Okay. Now I just do the math. 24 minus 72. It's going to give me negative 48. 1 minus 3, negative 2. 48 divided by 2 is going to be 24, and they're both negative. So the slope of my line is 24. All right, 24. There we go. So part B is asking, what does this slope represent? We have 24. Normally on a graph, we just have x's and y's, and we just say the slope's 24. But this example, we don't have x's and y's. Our vertical axis is measuring distance, and our horizontal axis is measuring time in hours. So the values of y, the vertical axis, are measuring distance. And then the units here are kilometers. And then my x-axis is measuring time in hours. So if I took my x and my y and said, okay, rise over run, or y over x, I'm going to end up with units of kilometers, because that's my rise, divided by hours, or kilometers per hour. So what does the slope mean? So the slope we found was 24 kilometers per hour. What does that kind of sound like? If I was driving to work and I was going 24 kilometers per hour, you'd say, oh, well, that's just how fast you were going. So what we've just calculated is how fast Yvonne was riding her bicycle. in the first, 3 hours, essentially, she was riding 24 kilometers per hour. All right. So how can we answer part B? Now, if I told you she was traveling at 24 kilometers every hour, how could we use that to kind of determine how far she went in 1 3/4 hours? So the idea here is in 1 hour, we know she travels every hour about 24 kilometers per hour. So in 1 hour, she's traveled about 24 kilometers. 1 3/4 hours, how far has she gone? So 1 3/4 we can write as 1.75 because 75 is, or 0.75 is 3/4. So every hour she's traveling 24 kilometers per hour. So if I took that 1.75 and multiplied it by 24, I would figure out how far she traveled in 1 3/4 hours. So the speed at which she's traveling multiplied the time at which she's traveling, it is going to give you how far she went. So 1.75 times 24 is going to give us 42 kilometers. We can do kind of the backwards sort of calculation. If I said, hey, she's traveled 55 kilometers, how long did it take her? Could we do that? Could we work backwards? So we know she travels about 24 kilometers in 1 hour, or 60 minutes. So if she took 60 minutes to travel 24 kilometers, traveling 24 kilometers in 1 hour. We're trying to find a time, how long it takes to travel 55 kilometers. So if we had 60 minutes to take 24 kilometers, 60 divided by 24 is going to give us about 2.5 minutes to travel 1 kilometer. So continuing that kind of train of thought, 24 kilometers per 1 hour. If you kind of flip it and say, okay, 24 kilometers in 1 hour, 60 minutes to travel 24 kilometers, that's 2.5 minutes per kilometer. And then I say, hey, she went 55 kilometers. How long did it take? You just say, okay, well, I could take my 55 kilometers and I could multiply it by the fact that it takes 2.5 minutes to travel a kilometer, and then end up with 137.5 minutes. Maybe we should divide that by 60 to figure out how many hours it is. So 120 minutes is going to give us 2 hours. So this is 2 hours and 17.5 minutes. All right, so part C, something that you won't, at least for the beginning, you won't have to do a bunch of these kind of word problems. So if you're doing good up to this last little bit, then you're going to be fine. Part C was just kind of taking the slope of the line and just going from there. You found the slope, 24 kilometers per hour. Can you do anything with that? Can you figure out how far she would travel in 1 hour and 3/4, or how long it would take to travel 55 kilometers? So just using that 24 kilometers per hour. That's kind of it for the lesson for today. It's the first one. Anybody have any questions? Anything I didn't cover? Anything that's maybe unclear? A couple questions coming in. Anything from Unit 5 you wanted to go over? We have a couple minutes left before we're done. So yeah, I don't want to confuse you guys with this last little bit. So if you were doing okay finding the slope, rise over run, using that slope formula, that's good. The definition's at the beginning, sure. So slope was a measure of how one quantity changes with respect to another. That sort of word definition